Alright, we're going to do a second example on completing the square. This one cannot be solved with factoring. The previous example could be. We didn't actually solve it with factoring, but that would be a good test of completing the square. In this video, we're going to use a polynomial or a quadratic that cannot be solved with factoring. Think about it. R squared plus 2r minus 33 equals 0. Normally we would try to set this up like this. Two binomials, r plus or minus something and r plus or minus something, and then we want to think of two factors of 33, say 1 times 33 or 3 times 11, but then those factors have to add up to a positive 2, and there's just nothing's going to happen that would allow that to work. So we're going to solve it a different way. Instead, we're going to solve it with completing the square. So a detail that I did not include in the last video was that the squared term has to have a coefficient of 1. So here's a 1 here. And we have to get rid of the constant term by putting it on the other side of the equal sign. So we're going to have r squared plus 2r, and we're going to add 33 to both sides, and I'm going to leave some space here, equals 33, because I just said 0 plus 33. So what we're going to do is we're going to build a trinomial on the left that is a perfect square trinomial. And again, as in the last video, you're going to take the coefficient of this term, which is 2, and here's the math. We divide it by 2, and then we square it. So in this case, 2 divided by 2 is 1. 1 squared is 1. So we're going to add 1 to both sides of this equation. Now if you take a close look at this trinomial on the left, you'll realize that it can be factored. In fact, it is a perfect square trinomial. It is r plus 1 quantity squared. And you could FOIL that for yourself and double check to make sure that's true. And on the right side of the equation, 33 plus 1 is just 34. Now again, as we said before, to solve this equation for r, we simply have to take the square root of it and then subtract 1. And whatever we do to the left, we must do to the right. So we're going to take the square root of both sides of this equation, and remember that when you take the square root, you have to put a plus or minus sign in front because you don't know if it's a positive root or a negative root. So what we get on the left-hand side is r plus 1 equals plus or minus square root of 34. And then we simply subtract 1 from both sides. And we get r equals negative 1 plus or minus root 34. Now 34 is not a perfect square. You can punch this into a calculator and get an answer. Now remember, this is actually two different answers. It's negative 1 plus root 34 and a negative 1 minus root 34. So you actually have two answers here.